Greetings, viewer. Welcome to my first real video, on developing a game. Here, you see a blue screen with an FOV slider. I'm going to cut that out, you weren't supposed to see that yet. And a resolution slider that is broken when it's on 3. But we'll keep it on 8 for now. Now you might think that this isn't all that impressive, until I back up. Now you can see that I can move around a 3D area. And I would agree with you if this was actually true 3D. But in reality, this is just an illusion of 3D. Alright, editing me here, I really should mention that this test that you see here is not what I finish in this video. This is a test that was written in Scratch based off of a tutorial by Griffpatch. Griffpatch is an amazing YouTuber making really easy to understand videos on Scratch game development. Link for his video is up on screen right now, and let's continue with the video. Because if I stop the program, you'll see. Let's just make sure I'm only looking at blue for an easy bit of contrast. That it is indeed just a 2D world. That this little arrow as the player is traveling around. Now, I'm going to stand right here. And I'll stop the program, and I guess I'm going to have to reorientate myself, because there you go. All rotation done. Now you might be wondering, how does this work? And, well, I need to know that because I'm going to be rewriting this in a different program. And I'll tell you why soon. But right now, I gotta tell you that this is using something called Raycasts. Not ray tracing. I'll explain the difference in just a second. But with a raycast, an object is spawned right at the center of the player. It'll find out where the player is facing, and it'll go a little bit to the left. And it'll send out a ray. And it'll go all the way to around here. And then it'll say, hey player, I've traveled this far. And the player will know, okay, that's the farthest left ray. And every ray will correspond to a vertical line, because you can see these are all actually just vertical lines. You can see little bumps at the top. So right here, it'll scale it accordingly. It'll scale it according to the distance. And then the player will send another one, and another one, and another one. It'll send a bunch of rays. And eventually there will be enough rays to make a vertical line for every little bit of wall in front of the player. And then the moment the player moves, every single ray is going to be sent again and again to find out how far away is the nearest thing. And then, well, that's it. That's the entirety. There's no procedural generation. I mean, all the popular games today seem to have beans in them. There's no beans. Well, I mean, technically the walls are made entirely out of beans. One could argue that they're beans. In fact, if I change this resolution slider, now everything is just a big fat bean. See? It's a sus 3D world. Now, ray tracing. It's similar to raycasting, but it is much more taxing on the computer. Because what a raycast does is a raycast will send out a single line of rays. A raycast will send out a single line of rays along the x-axis, and every ray will dictate a line on the y-axis. But with ray tracing, it'll do a single ray for every single pixel on the screen, which gives it these beautiful reflections, like the really impressive reflections, and amazing graphics. But it's seriously taxing on a graphics card. Because already, like, you can see here, sure, I have a crappy laptop, and its graphics card is around the equivalent of a GTX 680, so I don't really have much to go off of here. But I can tell you that even like this is quite taxing on my computer. Probably won't be for anyone else's computer, anyone else's modern computer, but it is for mine. And then can you imagine how difficult it would be to do every single pixel? Now, I realized that with this is written in Scratch. And Scratch, while it is amazing, Scratch is just amazing for people who want to get into programming and making games without much hassle. It's free, not sponsored, it's just amazing. It's a block programming language, and it's actually quite slow. If you download Scratch 2, I've heard it's a lot faster, but Scratch 3 is quite slow. And I could try and optimize the program, because how the Ray works, it'll go a little bit, check if it's run into anything. If it has not, it'll just, okay, I traveled a little bit farther. If it has, then it'll tell the player how much it traveled. It'll keep doing a collision check until it reaches something. But if it has to go a really long way, that's a lot of collision checks it has to do before the frame is drawn. And a lot of collision checks that's really taxing on the computer. So I could optimize the program. Okay, after a certain distance, the ray is just like, well, I guess there's nothing over there. And that wouldn't be too hard to implement. But, I could rewrite this in a different programming language. No, not Tinker. No, not Scratch 2. Or Scratch 1. I have no idea what Scratch 1 is. But not Scratch 1. I'm going to be writing it in Python, specifically using the Pygame engine. And there are a few challenges I have to overcome for this. First off, I have done nothing at this level of complexity. Like, you want to see my most complex project so far with programming? Yep, 270 lines of programming to make this. You can add a tree and a bush. You can see very crude animation. And you might have noticed this baby at the top left of the screen. That baby isn't actually part of the background, it's a separate object. Yeah, that's the entire program. Yeah, and this going into the third dimension, well, tricking the brain into thinking it's the third dimension, very complicated. I've never gotten an actual rotating script either. Like you see right here, if I pressed forward and the player moved like this, well, if the player was looking this way, alright, and I pressed forward and the player moved like this, that would be really disorientating. The player has to move this way if it's facing this way and presses forward. Or if they're facing this way and they press forward, they have to move this way. Not this way, not this way, not this way, not that way. They have to move forward. And I've never done that before. But I'm not going to let that stop me. I probably won't get this finished in one episode because it's a pretty big project. But I should get it done in around 2. I will, however, have a pinned comment with the entirety of the code. Anyone who chooses to download it, I'm sorry, I'm really not good at commenting. And you're also going to need to have Python down. You need to import Pygame and you also need to have a arrow image for it to run properly, but afterwards it should be perfectly fine. Yes, I am re-recording this after I've finished editing the episode because the original intro was horrible. Anyways, let's get into the programming. Okay, just realized that I forgot to include the clip where I actually show the difficulties I had in getting this little controller working. So in case you're wondering, it took me 5 hours, 3 different tutorials. Each of them were from, well, 2 of them were from a programmer, actually another game developer using Pygame called Def Fluffy Potato, and one of them by Sebastian League. I highly recommend the videos that will be popping up on screen right now. I highly recommend them if you're into math, game programming, or both. Probably. Alright guys, so now we have this little controller where we can control this arrow and move it around. And first off, this arrow, its movement is based off of its rotation, not the window. Something I've never done before. It's also rotating around its center, which requires a little bit of messing around to do in Pygame. However, there's nothing else but that arrow and also my mouse pointer. But so now, next step is we need to get something. We need to get something drawn, and then let's get some rays. All right, see you in the code. Well, so I've spent the past almost 2 hours now trying to get rid of this error I had here. And so this function it takes a color argument, x, y, width, and height. I've ordered these correctly in the function, and it should just draw a square somewhere near the top left corner. But it just gave me an error, saying the rect argument is invalid. So I messed around with the values, and I kept getting errors until I turned these into integers, which means I can't change them. And then it worked. So I knew, all right, I'm ordering these correctly. What could I be doing wrong? So I searched up the error, and I could only find cases where people were using a string instead of a tuple. Using a list here when you're not supposed to. But this isn't a list. And then I remembered something. Because you see, each of these, they're supposed to be integers, which means they're supposed to be a number. So, I realized, well, I can see what this function is trying to see. Like, I can see what I'm showing this function. If I turn this into a comment, and then I do this. And so this just means print the color, print x, print y, print width, and print height. Now I get to see what is the program seeing. And if I run it, you can see that color is fine, because color is supposed to be an RGB value. But then x is a class main object. The y is fine, the width is fine, and the height is fine. And so now it's the challenge is, how is that class main object? And I've just thought of something. If I turn this back into a comment, and I go, all right, editing me here. Long story short, this part didn't work, so I'm just going to save you the trouble. Now we gotta figure out why is it saying that it's a type object. Yes, let's see here. When we're setting up the object, the class object, well, what if I just I don't remember this being here. Oh! Alright. It works now. Alright, next challenge, you gotta get all I gotta do is get a single ray sent out. That's it. Just need to get a single ray sent out in front of the player. That's all we have to do. Alright, so turns out I actually forgot something, and that was making sure that the player could not walk through walls. And one thing leads to another, and I ended up kind of making an entirely new plan. Well, not entirely new. I can reuse some of the old bits, but it's mostly new plan of deciding where the squares are getting drawn. Previously, I just had two numbers. This is the x, this is the y, this is the width, this is the height. Go here, be this big. And the square would do that because square is loyal. But if I wanted to use more than one square, then I'd have to define individual one of those, and then with the rays and the player's hitbox, I would need to go, okay, if your x and y bigger than this, smaller than this, bigger than this, and smaller than that, and keep doing that for every single square. Which, if I'm going to load more than two squares at once, that is going to be a pretty big, pretty large amount of programming that I have to do. And I was like, there's got to be a more efficient way of doing this. So I started doing some research, and I found someone who was doing one in C. And this is how they structured their map. They split it up into little sectors, represented by either a 0 or a 1, with a 0 being air and a 1 being a wall. And I liked that, so I needed to come up with a way to convert that into Python. So what I thought of was every row was its own list, and a list is something you could loop over. And once I've looped over all of these items in the list, I can do something with them, with each individual item, every time I loop through. So I could then have these lists, and luckily I can actually have a list inside of a list. And now, a prototype of what we're going to do, and I'm going to write this in pseudocode, which is sort of like a mixture between code and plain English, so that you guys can understand. For every list in level, so that means it'll go through level and it'll see 1, and then once it's done with doing whatever's done with 1, it'll go to 2, and then 3, and then 4, and then 5. And for every list in level, for every, and remember, once it goes to 1, on the first when it first gets to 1, that'll be stored as a list. For every number in list, which in this case would be 1, if it's a 0. So if current number is 0, then we need to do, we just need to make it so that that is nothing, really. So we'll just go pass. Elif, which also stands for else if, which means sort of otherwise, if the current number is equal to 1, then we need to draw a square from the, for every lesson level, we also need to have a mini little variable in here to keep track of where exactly we are. So it'll be an empty list and spot equals 0 and 0, spot 1, and we're adding 1. So now here in 1e, the first part here will be 1, and then for every number, spot 2, adding 1. So now for this would be spot 1 and 1. For here, this would be spot 2, 1. Here, this would be spot 2, 3. Of course, spot 1 is actually here, because it starts with, technically it's actually just, that's how they're numbered, so it'll be 0, 1, 2. That's how Python sees it. But for simplicity's sake, we'll just treat it like this. And if number is 1, then we'll draw a square at the coordinates of spot. So 1e, 2, 3, 4, and 5. So if it's 1 and 1, so they can just be at 0, 0, constant, constant. So it'll be draw a square at 0, 0, which in Pygames, as far as Pygames is aware, is at the top left corner of the window. Constant wide, constant high. And constant is just going to make sure that it's always a perfect square. And now, let's say that it's actually at position 2, 2 in this situation, would be right here. So then, the coordinates would be 2 times constant and 2 times constant. And now, just got to work into turning this into actual code, because this was actually a lot simpler than I expected it to be. In fact, I'm even going to reuse this these lists here, because it's just, It's just so easy. Now, we'll just have this at the bottom. And time to start programming. Okay, so far, things have started to go pretty well. I did have an issue with, my understanding of the program, but that's all fixed now. So, now, the real test is, if I can get this to be drawn. If I change this to 1, this to 1, and this to 1, will it still be drawn? Yes! Yes, it's working! It's working! Yes! 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 Oh god, that is great. Okay, so while editing, I realized I forgot to mention. Now that I have this being drawn, I need to have like a little default map that I can draw. That way I can test things. I've sort of come to the conclusion that I should just do a square with a dot in the middle. That way I can make sure that outer borders of the world will work, and the inner borders of the world will work. And next up, I need to get hit collisions actually working. Did I actually just say hit collisions? Because the way that this thing works is it uses raycasts, but if the raycasts can't tell that they've been bumping into things, then the entire thing falls apart, because sort of the entire point of a raycast is to bump into something. Well, development has been going smoothly. I still have the ability to move the arrow around in relation to where it is. I have a system set up so that the entire screen is split up into a grid with either a 1 or a 0. And each area, like each spot in the grid, is 100 by 100 pixels. 1 means that A1 means that that spot in the grid will be covered up with just white pixels. If there's a 0, then it will. If it's a 0, then it'll be black pixels. But you see, I've run into a problem with collisions. Now, I've done a little bit to make sure that, like, when the player does run into something, they'll slide. But you can see it isn't perfect. In fact, it's far from it because it's a set. Like, it sort of splits the screen in half. And while where the area is drawn, well, that's dynamic, collisions aren't. And that's a bit of a problem. And I've spent almost a week trying to get a system out, trying to get a system working, where it'll just check where the player wants to move, and if the player's trying to move into a 1 on the grid, then it won't move the player. If the player tries to move into a 0 on the grid, then it will move the player. And I have gotten pretty much nothing but errors. Well, after a lot of messing around, I finally have a mostly functional script that'll allow me to not walk through walls, and after some messing around, now I can stop touching the wall. Look, even with the corner, doesn't let me clip through corners. For some reason, though, and I haven't been able to figure out why, it doesn't work with every wall. How? Let me show you the code. Alright, so here I have something set up with the here, walls.wallspace, and that would be this very long string, a lot of lists of data that you would see here. It's a very large amount. But you go down here to the check pixel and it loops through all of that. And it stores the x and the y coordinates of the current spot. So this will be 0x, 0y, 100x, 0y, 200x, 0y. Then, if the player is in this, then is in x will be set to true. If it's in it horizontally. If it's in it vertically, then is in y will be set to true. Then, if the player can move forward on the x-axis, then that's set to whether or not it's in the x coordinates. I know it's weird, but it works. If it's in the box, then it can move forward. I don't know how this works. If it can move forward on the y-axis, it's kind of the same thing. And I also have a system for if it's just in the square at all, because sometimes I have to remove that and remove that to get things working, or for like a testing thing. But here, if I remove this, then this is in square, just combines these two. So if they're both true, then it's true. If one of them is false, or both of them are false, then it's false. And when it's running, this is what it looks like. So I can still rotate, I can still move forward. This wall, this top bit still doesn't have collisions. Down here, this doesn't have collisions. This wall still doesn't have collisions. This one doesn't have collisions. And this one doesn't have collisions. So for some reason, none of them have collisions, which I find really weird. And so I did manage to get a fully functional collision script. However, I had to alter it to allow you to back away from wall. And then I tried to add sliding. And then I've ended up with this buggy mess. I barely even understand how collisions are, like how the collisions work in the first place. Because if you look really closely, you might see it's checking to see if it's in a square. Doesn't care what that square is, if it's in a square. It'll loop through every square. If the player is in that square, then it won't move the player. If the player is in one of those squares, it won't move the player forward. I genuinely, this isn't even me saying it as a joke, like I don't understand. It's like, moving forward with the sine wave and the cosine, that's like, I understand it now. I get how these work now. I have no idea what this means. I genuinely, like, I wrote the script last night. I genuinely do not know how I got anything working with this. This is just weird. And I can even just like turn these into comments. and then uncomment these, because this is one of the systems I also had set up yesterday. And now I can't move at all. Okay, I can move backwards. But also, it says this. Well, that's because I okay, so you guys can't see it, but I can't move at all. Okay, this is actually really weird. Why can my screen recorder only record one thing at a time? This is actually kind of cool. Now I find this quite cool actually, because now I'm trying to move forward, alright? Trying to move forward, left, right. Doesn't work. I can rotate, but there's nothing stopping me from rotating. But I can move backwards, and once I go into somewhere that I shouldn't be able to move, well, now I can move. I can't move outside the screen, because I normally would be able to move there since there's no wall there, but I can't. I should be able to move around inside this, but I can't. So if I just go ahead and reverse, if I just reverse the current script, then I'll have a fully functional collision script. And yes, indeed, I now can move around and not go through walls. I think I'll keep the ability to go backwards through walls, though. It feels like it could be useful for testing. However, now I have the problem of trying to get Raycasts loaded. And I've done a little bit of testing so far. So now whenever I press space, a new Raycast is added. For some reason it isn't drawing like I've told it to, but I have a little list that's storing where the Raycasts are and where they should go. Now the thing is, for all of those Raycasts, it's going to do a very large number of those pixel checks. So as I add more and more Raycasts, my mic might start to cut up, but you'll see the frame rate starts to drop. Because I'm having to do more and more of those pixel checks. And right now, this is like rendering one screen. Like I'd have to do all that work that's been done so far for just rendering one screen. Like that's at least my plan. Which is telling me that I need to optimize my program. And I've been thinking a bit, and how the current system works is it takes the middle pixel of where whatever thing is trying to go, and it'll loop through every single square. And if it just so happens that where it's trying to go is in a square that is drawn, then it says you can't move here. But the thing is, it loops through every single pixel, and it loops through every single square, which is more efficient than looping through every single pixel, but it's using the exact value of the pixel. And since all these squares are in increments of 100, that's 2 extra digits that are being digits that are being loaded. Now, I'm not an experienced enough programmer to know if that's a significant bit of a significant loss or if it's neglectable. But there's only one real way to find out. So now I have to figure out how to take just take the place of where the player is and find out just how many hundreds of pixels it is. I don't need the units, I don't need how many tens of pixels or how many 20s of pixels, how many pixels at all. well, how many single pixels. I only need to know how many hundreds of pixels there are. And then all I have to do is check, is it equal to a certain coordinates of a square? Not is it larger than this amount of the square or smaller than this for every single square. It should, in theory, speed it up. Let's see how it goes in practice. Well, about 2 days worth of testing and messing around later, and I now have a function that'll take a number and then return how many hundreds are in it. These are the most entertaining names I have in the entire program. Stringo, Bingo, and Inty Binty. However, I noticed that it wasn't working. So I tried changing the player's collision checks for that, since I right now I can't even see the raycasts and they're moving. I should be able to. I'm telling them to draw, but they aren't. But I am drawing the player. So I edited the player's script to use this new system, and well, collisions just don't work anymore. So I added this code to make it so that now it'll draw a square at where it thinks the player is. 100 pixels wide, 100 pixels tall, and I seem to have messed up. Okay, I have only been drawing it at 100 pixels from down and to the right, and not at the player's position. Now, let's run it. Okay, keep in mind this square is only going to be drawn when the player is moving. Okay. So I think I see what's going wrong here. Alright, so it's only... Alright, I understand now. I understand. Give me one moment, I'll be right back. Alright, I've made a few changes. I haven't changed where the square is being drawn, but I have changed what values are stored for the location of these squares of these other squares, and it's still not working. Alright, so now I've evened out the equations. It should, in theory, work now. Okay, that's good. Collisions are now functioning once more. Let's just change this green square to make it accurately represent where the player is. Okay, so keep in mind the green square is only drawn when the hit collision is run. So now this square should, in theory, follow the player. In practice, it does. It does. Now there's no hit collision being done when I go backwards, so that's to be expected. If I go backwards into here and I try to move, yep. Yeah, that green square is going to be following the player. This is surprisingly bugless, actually. This is quite impressive. I can definitely see this being useful for pathfinding if I ever end up doing that. However, very unfortunately, this video has been absurdly long already. So I am not going to be able to complete this renderer in this video. However, I'm still going to complete this renderer. There's no doubt about it. So if you like this kind of content, and if you want to see what this renderer looks like once I've got it fully working and looking like it's in the third dimension, please smash that like button. Gently press the subscribe button. Make sure it feels loved, but don't hurt it. Leave a comment so that anyone else who likes this content gets shown it by the YouTube algorithm. And I will see you once I've completed this absolute behemoth of a program.
You thought that was the end of the video. Not quite, as I have something else that's yet to be shown. Because if I head onto my Raspberry Pi here, and I go run, you can see Python getting all set up. Then we look down here, and a few LEDs turn on and off in order. And once they're all done with that, the camera's gonna probably get a bit jittery here, because now I have full... I guess I didn't focus on the window, because now I have full control over each LED other syllable here, using the number keys. And I've pretty much made my own display here. So you can bet your butt I'm making a game with this in the next video.